Hey, so welcome to Fusion 360, the Freeform and T-spline modeling environment. Today we're going to be going to do a run through of the various tools and utilities available to us. So let's just get started here. In our solid modeling environment, we create a form, and under the create drop down we have a variety of shapes available to us. Box, plane and cylinder are going to be our main ones. These tend to be the most versatile, but we also have sphere, torus, quad ball, which aren't as useful. They tend to be just a bit too complex starting out with. Pipe is actually quite useful. This is similar to the pipe environment that we know, where you can extrude along a sketch line. These pipes tend to be more organic and actually nearly easier to work with and manipulate than standard pipes. Face is similar to plane, but yeah, equally as useful. And then we have extrude, revolve, sweep and loft, and they're exactly like what we know, but in a freeform environment, and they're useful, but for now we won't get into them too much, because generally it's easier to start off with one of these basic shapes and make them into manipulate them into the shape you require, rather than extruding them. The reason I'm saying this is because when you generally extrude a shape, you end up creating more faces and edges, and that just makes the body difficult to work with. So to start off with here, just run through some of the modify tools, and we'll do this by first creating a box just so we can visualize what I'm talking about. So when we create a form, we have a variety of different controls here. We can change the number of faces or scale it up and down, etc. So here's our basic formed rectangle, and this is currently in smooth display mode, right? It's visualizing the 3D splined faces. This is useful for seeing how your geometry is coming along, but generally when we're manipulating the geometry, we want to be working within box display mode, and we can do this by hitting Alt 1 and 3 on the keyboard, and this will just cycle between these two. Alt 1 is box display and Alt 3 is smooth display. Likewise is Control 5, 4, 5 and 6. So 4 is completely smooth, 5 is visible and hidden lines, and 6 is just visible lines. So generally I like to work in Control 6, which is just visible lines, and in box display mode, Alt 1. So now that we have our basic shape, we can begin to manipulate it somewhat. So we have under the modify panel. Now I have pinned some of these to my taskbar. I can't remember what the default settings are, but you can pin them as you see according to how often you use them, etc. This is the bread and butter of the freeform environment, is the edit form tool, and it's quite powerful. It allows us to manipulate faces in all of their axes, perform rotations, scales, and yeah, just allows complete manipulation of them. However, one problem with it is that if you're trying to scale a face here, I'm trying to scale that, it's tricky to grab without grabbing something. I'm selecting a vertex there, but if I was selecting a face, it's tricky to grab the right manipulators sometimes. So what we can do is, under the transform mode and selection filters, we can change some of these as we see fit. So currently I'm in the multi tool, which gives us a selection of all of these different axes, but we could, if we knew we were only translating the faces, we can just select translation. This cleans up our bug way more. Likewise, we have rotation and scaling. So it just cleans up the environment, makes the tool easier to manipulate. Selection filter then is similar enough. If I'm only working with vertices, and I'll go back to multi here, but if I'm only working with vertices, I can allow it so it won't allow me to select faces or edges, because sometimes if I'm on the all here, it can be actually quite difficult to select the exact thing you're looking for, and sometimes you can end up selecting one or more. So keep in mind that these tools do exist, and it really can speed up your workflow. If you know you're only working with vertices, just select the vertex filter. Likewise with edges or faces. Now, some of the other tools we have available to us are insert edges. This will essentially divide up our model and give us more control points. And we have single. First of all, we have exact, which will actually make our model. I'll just demonstrate what that will do. It makes our model very complex because it's trying to keep the exact shape we have. Whereas insert edge in the simple mode, which is the most useful, will just insert the edge 50%, which is this multiplier here, between this edge and this edge. And we can change that. Let's say we want a sharp line here. We'll bring that control edge closer. We'll do, let's say, 0.1. And we want to go both sides, so we'll do double insertion. Now, this doesn't look like much in the box display mode, but in the smooth display mode, it looks like nothing much either, but it allows us to manipulate these edges and tighten up that curve. So I'll select the edge filter. Select those two edges. I'll extrude them up a bit, or manipulate them up even. And obviously, double clicking will give you the chain select, so that can be useful sometimes too. So because I've now inserted these two edges here, I can actually create a pinch point within this geometry and make for quite a sharp radius here. And going back to the smooth display, now we see we have, it's not a crease, but it's a sharp kink in the form. So that's why inserting edges is beneficial. It allows us to add more detail. But one important thing about working in the freeform environment is to just be mindful of how much detail you're adding early on in your designs. Because let's imagine now I've introduced that detail there, and maybe I've introduced another edge as well. We'll do just single here. And I'm happy with this edge now, but now it comes time to work on this face, and all of a sudden I have all of this geometry to manipulate, and it just tends to be harder to keep everything smooth. So the best practice within the freeform environment is to only add detail as necessary. And if we overdo it, feel free to always go ahead and delete it. And this is why Fusion's T-spline modeling is just so important, because or so powerful. Because we have the ability here to have this T-junction here, which actually isn't the standard. I don't know if it is anymore, but it definitely wasn't when this tool came out. You couldn't just have intersecting lines here, splitting a line in half. So you would have to continue this geometry the whole way around, and it would just make the shape incredibly complex very early on the design stages. Whereas Fusion allows us to avoid that issue. Now, you do get weird geometry when you do it, so generally it's good to keep the lines continuous, but it's not always necessary. And the important thing is that we have the ability there to avoid those issues. So as well as insert edge, we have subdivide. This allows us to split up the face. Again, introducing more detail. See there, I selected an edge by accident, so that's why it's a good idea to have those selection filters on. And we can just manipulate those edges. As well as that, we have insert point, which tends to be more precise than insert edge. Maybe I want to just connect these 2 points here again. That's what insert point allows us to do. You can do that continuously as well. So, splitting that up into loads of triangles. So let's go into some of the other tools. So merge edge and all of these tools here are all within the same family, as I said. And this will allow us to, I'll just demonstrate here. So let's delete these 4 faces. Here's where counting faces is important. I must have the same amount of faces on this as I do on the sphere or the body I'm trying to join it to using a bridge command. Now I can demonstrate how this would go wrong. We can do an insert edge here. Let's make that 50%. Okay, and let's go back to box display mode. So just if you have multiple bodies in the view, you have to select them to select box display. So let's do a bridge here. Now this is quite a useful tool if you're working on individual shapes and you have the faces matching and stuff. It saves you having to actually manually make all this geometry in between. You can just use the bridge tool. So select the first edge group and the second edge group. Now you can see here we get a warning. The edges from one side must be equal or to the multiple, and it won't even let us select that. So let's just go back here, delete that face, and we'll try that again. And oh yeah, so now it's allowing us to bridge those. We also have the option to follow a curve. So if you put a sketch on this plane, you could put a spline there or something, and it would try and follow that curve to bridge the thing. Faces. This means, and we can actually preview that there. This is the amount of faces in between the two shapes. So if we want more detail, more control, we can increase that or decrease it as you see fit. So we'll just do that for now. And if we go back to, again, select the body. So we can see now that created, a fairly neat bridge. Not perfect, but we will look at the merge edge tool now. This is useful if you have holes like this. You can select multiple. You can do chain select, but generally you'd select a few. This will create problems because these edges won't be welded to the. I'll just show you now. So it's going to create a mess of our geometry. So this would actually be a good time to display the repair body tool. This is really useful once you get messed up geometry, because it's actually quite good at doing repairs. So we can just select auto repair. Select our body first, and if we hit auto repair, it'll do its best to fix whatever mistakes we've made. And it's not perfect, but definitely if you're running into issues, you can always try and just do an automatic repair body and see if it helps out your geometry if it ever becomes messed up. So we also have weld vertices. Now this gives us way more control than merge edge, especially when the geometry starts to get complex. Merge edge just might not have that level of detail that you get from weld vertices. So we can weld all these together and we'll create a mess. Yeah, likewise. So, and you notice there that it actually went into box display mode. That's if we have a serious problem with our geometry. It won't even allow us to go into smooth display. So that's because we just have unwelded vertices there. So once we've done that, it's not exactly nice, but we do have a smooth body. So that's our that's these tools here. Fill hole, self-explanatory. If you have a hole in your part, just select the boundary loop. So let's just do that real quick. Again, these are all just time-saving things. Reduce star, we can do fill star, or we can do collapse, and these are different modes of connection. I notice here we have 8 intersecting nodes. It's generally not good practice. It can create pinch points in the model. As a good rule of thumb, it's best to stick below 5. So if I just go into here into smooth display, this is not going to give me a good example. It actually looks fairly smooth, but sometimes you can get weird distortions if you have multiple faces going into one node like that. So just be mindful of that when you're. Yeah, there we go. You see, it's such a sharp pinch point that it creates a pretty bad geometry as soon as you start to manipulate faces. So that's just that tool. Crease and uncrease, as well as bevel edge, these are all tools that allow you to introduce more detail and refine edges. So at the moment these edges are fairly soft. Let's go back into box display and let's start with crease edge. So we'll select this edge group here, and if we go back into smooth display, it's crease the edge, and reverse is obviously uncrease. Bevel edge then gives us a creased edge but more control over it, so we'll try it on this edge here. And we can, this again is the multiplier. It's the same as your insert edge. It's a multiplier for how far away you want that bevel to be. So if we want it tight, you'll go 0.1. That will bring those edges really close. And likewise, if you want a nice soft curve, move them further away. So this will create a crease, but have it be much more controllable and not as sharp. Now, if we decided it wasn't tight enough, we can slide edge and bring those edges closer together. It's actually showing us the box display mode here in a wireframe version, which is just useful for seeing where those edges exactly are. So that's your bevel edge. Insert edge then is similar again. You can use that to introduce more detail locally and tighten up edges. Now you can see we're getting poor geometry here from the crease. This is why it's generally, they're grand for some stuff, but generally it's better to use a bevel edge or insert edges to create sharp edges. So cylinderify actually applies here because we have somewhat of a cylinder. So we'll just see if this can actually fix the issue. And it does its best, but it's not great. However, if you had something really lumpy, it'll do its best to bring that back into something cylindrical. So again, not perfect, but it can help out. So another one of these tools that is quite useful is the flatten tool. So if you were working on a body and you're just from the process of modeling it, all your vertices are just not on plane, we can use this flatten tool and select our vertices and pull them to a plane. Now we can also do a fit mode. So this will try and, you can see it's flattening them out there, and it's taking the average between them essentially. So it actually creates a perfectly flat face for us, albeit at an angle. But where it's more useful is if you're trying to make two components together, you can put a plane in between them and pull to a plane. So we'd select this plane here, and now it has pulled all those vertices flat to this plane. So that can be quite useful if you could imagine we had a mirror. So actually let's do that real quick. Sorry. So a mirror along this plane here, and now we can weld those edges or merge those edges. It's actually, sorry, it's already put the symmetry on that for us. So yeah. So that's an example of the pull tool. Match is if we had a, let's go back here and we'll do a sketch on that plane that we had. So let's just create a sketch here and do a spline. Let's just hide that body for now. So match edge, chain select that edge, and we'll select the sketch, and it'll do its best to pull it and match that geometry. It's never perfect, especially if I'm pulling to a spline. You're going to get gaps. And the way you would solve that is by increasing the amount of edges. You could subdivide these faces along here. Yeah, we've different modes here that we can select through. And fall off as well. This dictates how far back in the model it affects. So this isn't a great example of it here because this edge is so close. But if this body was further away, the fall off would be how far back it starts to merge into this shape. So we're just going to do a quick workflow here. So on what was the project last year, which was a go-kart, and we were asked to make a go-kart sidepod. So let's import that canvas there, just to give us some reference geometry. The scale of these doesn't really matter, but we'll just scale it up for now. So I'm going to start here first by creating a form and going into the face tool. We'll select the work plane and we'll just start by arbitrarily assigning points here. It doesn't really matter for now because we're going to be manipulating these anyway. We'll OK to that. And at this point we'll go into the edit form tool, select our selection filter to edges. It just makes it easier to work in. Now I'm in smooth display mode, so I'll just go back to, so we'll do that, and that's just control 4, 5 and 6 for changing the edges. So I made a mistake there. I was supposed to hit Alt and extrude a new edge. I can just scale that down and just rough in this geometry to get started. Do the same here for the back. I might just scale that up a small bit. Notice I am in smooth display mode, so I'll just go Alt 1 to go into box display. This will just give us a better view of what's actually happening with the geometry. I'll pull this plane out now from the work plane. We'll say maybe 100 mil. Doesn't really matter. And we could even start to just get this into 3 dimensions. So I'll select those 2 edges and using our cursor we'll just do a pull with using the Alt key and bring that back minus 100 mil. Actually, you know what? Yeah, we'll just leave it at 130 for now. So if we just go into smooth display there, we can see this is very curved. We're not matching our geometry here at the top or the bottom, and the back needs that kind of, it needs to follow the profile of the tire a bit more. So we'll start by adding in some control points. I might close off these edges first, so it'll give us a better feel for how the geometry is playing out. And just to make life easier, we'll just scale that down a bit to make the welding of the vertices easier. I'll do the same here for the back. Yeah, that's good enough. You could do a merge edge here as well, but I just find you get more control with the weld vertices. And that'll close off that model. So if we come into the 3D, it's very curved now, and it has the approximate shape, but we definitely need to refine that a bit more. I might start by creasing this edge to make it a bit more boxy shaped before I do this dovetail thing at the back here. We might actually modify the front here, just carve that out a bit more first, and then we'll do that crease. So just notice now at this point I'm going to start working in plane. I'm going to stick to using my view cube up the top here to ensure I'm not working, because it just makes life easier. You tend to be able to align your geometry a bit more.
just see how that looks in a second. The top isn't looking too bad. It's fairly consistent with the canvas. We'll just see how that looks though. So yeah, the top face and the bottom face are fairly consistent with the canvas. So we'll continue on now, and we might add in an edge along here. And I'll just do an insert edge. Okay, so it's only allowing me to do one there. It's not allowing me to do the chain select, but that's fine for now. So we'll do both, and we'll do a 0.2 for now. We can adjust those edges later. Now, one thing you should notice is that even though Fusion allows us to do T-splines, there's a time and a place for them. So when you have a sharp radius here, as we do at the front, or a fairly tight turn, it's not a good idea to place a T-spline there. I'll see what the example. I'll show you the smooth display, and we'll hide our canvas there. So it's not a perfect example, but you can see the geometry is quite pinched there at the front, and realistically we don't want that. Same at the back here, because we have a T-point right on a curved edge. So if we come back in here to box display, what we're going to do is we're going to carry that geometry around to a flatter area of the model, and we can insert the T-point in on this face, because there's not much curvature going on here. Likewise with this part, what we might do, we can either wrap around this face, or we can bring it down, or we could even try and delete it and just see how that looks. This face isn't particularly curved compared to this face. See, it kind of gets rid of the kink. It still is quite tightly creased, which is kind of the effect we're going for. So I'll leave that like is for now. Now this is very planar still, like there's no depth to this at all, but we'll focus on getting the rough shape first before we make finer adjustments to it. So into box display mode, and we'll start work on the back of this. We'll carry that geometry around like we did with the front first, just to get rid of that crease. We'll keep this edge tight, as with this edge. And then we can feather that off. In fact, we can bring it into this point here. And by bringing that point away from the edge, it just means that this corner here is going to be a bit more curved. And we'll keep it tight then against these corners. And this one I might move out a small bit more actually. So just selection filters again. And we will work now on this dovetail area at the back. So we'll bring back our canvas there for a second. I would say that these 2 points are almost in the position we want them. Well, they certainly are in box display, but because we haven't defined that geometry very well, they're not going to be in the correct location in smooth display. So when we start to insert edges here, you'll notice that it will increase the sharpness of those. So let's just first install a center line roughly, and we can make a T-point on this face here, because again, not much curvature. And we'll do an insert edge then, a double, just to sharpen up that geometry. 0.2 should be good. Now I already don't like that there, so we'll just bring that down. And notice here that I'm going to try and keep lines consistent, parallel, and just overall, you want, when you're in box display, you want your geometry to be nice and consistent. Even though it might look good in smooth display, it's always better, and it makes finding problems as well in your model easier if your geometry is nice and clean inside the box display mode. So it's just a good habit to get into, of making sure everything's aligned, and just makes life easier. So we carry this point across as well, just keep that T-point out of the way. And so now I'm taking my time here with this, but Obviously in the competition you're going to be working under a bit more time pressure. However, I cannot stress the importance of just, getting that base geometry correct. If you start having rough geometry from the start, you're starting off on the wrong foot completely, and you're likely to get a pretty bad looking model. Freeform is a lot about patience and just seeing what works. So actually, instead of doing that, what I'm going to do is I'm going to chain select this entire edge, and I'm just going to scale it down a small bit, and that'll just bring in that bevel a bit. Now I don't like this geometry here, but we'll clean it up afterwards. We'll just see how that looks for now. So yeah, you can see we tightened up those edges now a bit more. It's a bit boxier shaped, and we have the geometry in place to start manipulating these back edges. These aren't tight yet, but we can work on that in a minute. Also, good practice is I'm ending my T-points here, but they're all spaced quite tight together, so it's not a bad idea to space these out. And that just means that if they do result in any kinks, which they sometimes can do, on a smooth face even, that they're not as sharp, and you're less likely to get problems in geometry by spacing them out a small bit, so it's no harm to do that. So just notice all my lines nice, consistent, relatively parallel, and even the ones that aren't, we're going to come back to them and clean them up. So select these two edges and these as well, I suppose. We'll just pull them back and see how this looks in smooth display. So yeah, definitely need to tighten up this corner. So we're just going to do that now so we can get a feel for how our geometry is coming along. I'll just do insert points. I could do a slide edge, or sorry, an insert edge in this as well, but generally prefer insert points. And we'll bring this back up to center there. So yeah, we've sharpened up this corner. This corner is a little bit duller compared to it, but we are now starting to form that dovetail. So we can compare this now to our geometry, and at this point it's safe to work in smooth display mode, but just by manipulating faces. Don't go manipulating vertices or edges. You can do, but it's better practice not to. We can just select faces. I won't select these faces here because they're very tight together, so I'll just pull that into position for now. It's not looking too bad, and this one is not looking too bad. This area here is maybe a little sharper than I'd like still. We possibly haven't, oh yeah, we need to repair our geometry there over there still, so that's the reason for that. And we can feather this out a small bit more so they're a bit more consistent with one another. So at this point I might start cleaning up some of this geometry and just manipulating these points so they're producing nice curves rather than sharp edges. Keeping these faces parallel. I'll do the same with this face here. I'll bring this point up. We can just get a more gradual slope into the flat face we have on the bottom here. I can look at it then from the back and make sure all our geometry is clean here, and it actually is fairly clean. It doesn't need to be perfect because we're still going to be manipulating these points, so you don't need it to be 100% for now, but we'll just see all these faces are nice and consistent. This point could be brought down to match the slope of the one above it, as could this one. And then this face obviously here is a disaster, so we'll start cleaning this up. And again, keep yourself working in plane mode, using your view cube up the top here to make sure from all views that the geometry is well positioned. I'm going to fade out this curve, so I want this now to be more triangular. But we'll keep a consistent enough gap here at the bottom. So you're getting all your points in line. Just make manipulating the geometry easier. Now we're going to have to do something with the edges around here because we have a lot of broken edges, and well, by a lot I mean one. We've one broken edge here that we probably want to address, so we could just delete it and see how that works out. Now we do have 2 points here. Sorry, we don't. Start point here and T point here. But we'll just see how that looks in smooth display before we go any further. Yeah, so we definitely need to address this front here a bit more by keeping our lines consistent, but the back here is looking fairly good. And it's not perfectly matched to the geometry, but that's not really the aim of this video. It's more to just demonstrate the workflow of how you take a desired shape and start roughing it in, producing that geometry. So let's address this front here. So we have consistent lines at the front here. We don't at this side. So what we could do is actually just delete this as well. And we might try this. We might try it and it might not work. I mean, if so, we can just delete it, but we'll carry these points around. No, I won't do that because that makes a 3-sided and a 5-sided shape. I'll keep them consistent and have 2 4-sided shapes. So this is technically a 4-sided shape. In fact, we can force it to be 4-sided by just doing that. And generally Fusion, or T-splines in general, prefer the 4-sided shapes. You know, like this isn't ideal. So we might have to, this may create a bit of a kink here at this point, and we can look at that now and see if it does. So yeah, we've definitely cleaned up this face by just introducing those lines and continuing those clean curves. But as suspected, this area here is just a little bit, it's just something not perfect about it. So we'll just go back to that and try and address that issue. So one little trick here that sometimes works, we can do an insert point here. We can grab that point and now we turn this into a 4-sided shape. That does make for some weird geometry, and so what we have to do is close this against this, and so now we have all 4-sided shapes meeting, apart from this one which is now 5-sided, but we'll leave that for now. We could continue that curve around to here if it created a problem, but we might get away with having the T point on this face here. So that's not looking too bad at all. I'm happy with the nice smooth radius on that, and the tapering of these sharp edges here at the bottom into the more rounded nose. And I might actually replicate what I have on the bottom here on the top, get this edge a bit sharper. I think it would look better. So we can simply do that by manipulating this top edge and fairly repeating this gap here we have in the bottom. And we look at that from the top. We'll tighten up this edge. Okay. At this point, we might just add a bit of 3D geometry to this face here, and we leave it at that because we've covered the majority of things I wanted to display in the workflow. Is just the consistency of points, and even at that, you know, some of this geometry isn't perfect. I would definitely like that a bit smoother, but you know, realistically in the competition you're not going to have time to address every little vertex and make sure it's nice and consistent, but definitely while we're practicing and while you're learning how to do T-points, it's a very good practice to get into, and in the competition then you can, you know, decide whether it's necessary. But when we're practicing, it's always a good idea to keep everything consistent. Nice parallel lines where we can. So we'll leave that for now, and we'll go on and make this a solid body. After I'll just extrude these faces in a small bit. Give this a bit more. We'll just see how that looks. So it doesn't do much for it. Just we might do the same on these faces. Yep, okay, I'm happy with the shape of that now. So when we're finishing off a body, counting faces is extremely important. So what I'm going to do here, I'm just going to demonstrate how we'll do, how we'd close this shape off. And that's by selecting the point with fewer faces. We could also close it off from the back forward, but then we'll end up creating a lot of T-points here at the front. So we'll go from the front backwards where the fewer faces are. So first of all, hitting Alt, and now I should be in box display for this actually, sorry. Hitting Alt, and we'll bring this back to this point here, where there is a seam already in our geometry. This means that this face will line up nicely. We'll bring this back and this back. And we'll continue to extrude this back to this point here. So holding Alt again and just pulling that back, we can manipulate this into the center a bit more. And you can see here now our lines are going to meet up nicely when we do a merge edge or a well vertex. And once more. But now notice we have an uneven number of faces here right on a point where we are developing curves. So we're definitely going to want to extrude these T-points back, maybe to this face here, when we start welding these vertices. So we might do that before to just make life easier. So we can do a point on this face. This weld here, this weld here. This needs to be split in half. And so these faces will weld to there. Then this face will weld to these two faces here. So again, another insert point. And we actually may carry these T-points back in a minute, but we'll first weld it and see what our geometry looks like before we do anything. So just begin by welding these points here. Now, yeah, no, those are already welded. And by doing that, we've ended up with all four-sided shapes, or faces, and we've no weird geometry, no overlapping. And that's why I generally prefer weld vertices and merge edge. So, you know, you could chain select that entire edge of faces we made and weld them to this, and generally it will meet them up because this is actually a fairly simple geometry, but sometimes it doesn't, and sometimes you get vertices where, you know, the vertex here would be welded to this point, and the vertex that should be on here would be welded at this point. So you get this twisting effect, and it creates a kink in the geometry that's actually hard to see even in box display. So that should be good. We'll actually take a quick peek at this in smooth display mode. Okay, so it's not letting us, so that tells us that we do actually have a geometry issue. So we'll just do a repair body on this, see See, it even doesn't like these T-points that we've created. So we'll just do an auto repair on this, and it's converting these T-points into start points, which we don't want, to be honest, but we'll address that in a minute. So yeah, clearly we need to crease this inside edge here. We want to actually maintain that sharpness. So what we'll do in here is we'll do actually bevel edge would be better for this since we have consistent geometry. And where are we? Bevel edge. Now it might let us do chain select or not. Okay. And 0.05 should be good. That'd give us a nice tight curve or tight bend. And to finish this off, we'll just clean up some of these T-points in geometry. Keep them all consistent. Not looking too bad. And we might convert some of these into, bring these T-points forward a small bit. That should give us a fairly clean geometry. We know it's worked for this face where we've brought all our T-points forward, and actually we've continued these on. But since we've such a sharp crease on this, I think we might be okay to leave them on this face. So we'll have a look at this. And again, it's not letting us. We'll make uniform on this one, see if it does anything. Uniform, okay. Repair body. It's still not happy with these 2 points. And I'm pretty happy with that geometry there. So we'll leave this and we'll finish this form, convert it into a body. And this will be sidepod. Now, in last year's WorldSkills competition, obviously they wanted us to make the sidepod, but it actually had to attach to the go-kart. So whilst this isn't freeform, I just want to show you how you might go about doing extrusions through freeform and interfacing with other objects. Now, obviously this face is going to be difficult to work with because it's so curved, as are these faces in the front here, but this face is flat in this case. We just got fortunate with the design of, what was asked of us. So realistically, you could even create planes on that and do sketches and extrude features that would be merged as a body. So you'd get away with that in that case. Push pull can also work on these shapes sometimes, depending on the geometry. Didn't work there, but we also have the ability to shell. Now, if you're doing a shell on something like this, sometimes it will allow you to select a shell to face off of. In this case, it won't. But if we had a cube, we'd be able to shell that and select the top to leave open. So we can just select the actual body from the menu and put maybe a 4mm shell on that. Give it a second to calculate. And now if we run a section analysis, let's see, we've hollowed out that part there. So that can be useful. You could do a split mold or whatever on this. You could split that body and have it a 2-part kind of clamshell design. And you could even extrude a lip onto this. But just to demonstrate something that you may be asked to do is, we were asked to attach this to the go-kart. And last year, we had to attach it to a pipe that had to go through the body itself. So actually first we're just going to delete that shell feature. Okay, didn't like that at all. So what we'll do on this is we will just create a sketch on a plane and extrude up the pipe as it was in the competition. So go back to do new components for these, and we'll just call this frame. I'll create a sketch on our origin plane. We'll just do a rectangle like so. And I'll put a fillet on these corners. Actually, I meant to convert that to a construction line. And now we can do a pipe command on that. We'll just make it 25mm pipe. So at this point, the pipe is being extruded through our body, and that's great, but realistically, you're not getting that in there. So we need to make a cutout on the bottom. There's a few different ways of doing this, but you can make this as simple as or complex as you want. An easy way would be to project a sketch onto a plane underneath the side pod and project this entire pipe, maybe offset it by a mil or two, so you have some clearance in there, and make an extruded cut back up and then radius the internal corners there. That's one way of doing it. But we might do a split sketch on this. So what we'll do is we'll do another component just to keep the sketches out of our work environment. That means all our sketches are contained within individual parts. Actually, sorry, you know what, don't do that. We'll go back and we'll activate our side pod here. That'll keep that sketch within the side pod itself. So we'll just do a sketch here on our this plane. We'll slice this and we'll do a project include. And we want to do an intersect. So we'll select these profiles in the pipe. Hit OK to that, and we'll offset these by some distance. We'll do maybe 2mm offset. Actually, no, I'm thinking about that the wrong way now. We want to offset this line to the halfway point of this pipe. So that it meets tangentially. And so now that's given us a center line on that pipe. All we can do is close off these 2 points here. That'll give us an extrudable area. And just make sure that we don't cut into the other body. You can just do that by hiding it, or you can just deselect bodies when you do an extrude, but yeah, select those two. We want to do a symmetrical symmetric. We want to do a whole width and 25mm, or what was our clearance? It was 2mm clearance, wasn't it? And make sure that's only cutting. We don't want to cut the frame. So we've cut out the square, or the square section for that, and it's meeting tangentially to what we will cut out now in a second, which is the pipe profile. So what we can do here now is we can open this sketch and we'll do a pipe, make sure we're still activated in this here, and we'll turn this on to 28. That's our 2mm clearance. We'll do the cut, we'll make sure it doesn't cut our frame, only our side pod, and that should be good. We can hide that sketch again. And now we've created a cavity within our freeform model that our pipe can fit into. Wherever it's gone. Oh, we need to activate this. Okay, so we've done something weird here. In our okay, I think that's a visual glitch or something there, but give me a second there. Yeah, okay, so there was just a visual glitch there. I don't know what happened, but I just reloaded the model. And as you can see here now, we have our pipe with clearance slotting into this model. Now, I suppose you'd have some type of locking mechanism on there somewhere, but for now, that'll do. And that's just one workflow of the freeform modeling workspace. But, you know, I definitely encourage anyone to just try and model components that are around the house, on your desk, whatever. And like I was demonstrating earlier, to keep that geometry as clean as you can and take time with doing your objects, and that'll encourage you to get quicker as well. If you're in the competition, you won't have time to make the perfect geometry, I can imagine, but if you're practicing keeping your geometry nice and clean, it'll just come second nature to you at some point. So as you can see here, you know, our shape is quite clean. We've no kinks or creases. Definitely happy with that. Look, you can always play around with these for as long as you want and keep improving, keep tweaking. But, you know, in the competition, you're not going to be doing that. So it's good practice to get into. And yeah, best of luck.